In the previous movie, we developed a script to randomly vary the relief and arrangement of our game board. In this movie, we'll create a user interface using Qt Creator to interact with that script. You can start by opening the file Family Game Night Final or using the scene you developed in the previous movie. If you load and run the terrain editor Mel UI script, you can see we've added a user interface with some additional Mel scripting. In this UI, slider widgets drive our terrain relief and rock tree generation, while buttons call each of our procedures. For an in-depth look at creating a similar UI using Mel, see our Creating a Zombie Simulation using Mel tutorial. However, Mel isn't the only way to create a UI for your code. You can also design UIs visually with a development kit like Qt Creator. You can download Qt Creator from the Qt homepage. Note that when installing Qt Creator, you may encounter warnings about unsigned drivers that do not meet certain platform compliances. If you are uncomfortable installing these drivers, then you can stick to creating UIs using MelScript. With Qt Creator up and running, go to File, New File or Project, and create a new Qt file using a Qt designer form. We're going to use the Dialog Without Buttons template with an initial size of 240 by 320 pixels to create our UI. Let's call our UI file Terrain Editor and place it in the same folder as our current Maya scene. The summary form gives you project management options, such as version control, but we won't bother with that for this tutorial. The Qt Creator shows us a template representing our window. Go to the Q Widget section of the Window Properties and change the window title property to Terrain Editor. Let's create a simple title label for our first widget. Scroll down to the Display Widgets section in the left panel and drag a label widget into the window. Double-click the label and rename it Terrain Editor. Now in the Q Widgets section of the Properties, click the Font Property field to edit it, and then the button to choose a custom font. Set the font to Century Gothic, font style to bold, and size to 16. Now press Ctrl J to resize the label to fit its text. Next, we're going to import an image label. Drag a second label widget into the window next to the title. This time, scroll down to the Q label section of its properties and select Choose File from the drop-down menu of the PixMap property. Navigate to the Icons folder and select TE Logo. Once again, use Ctrl J to resize the label so the image fits. Then arrange the title and image side by side like so. Next, we'll add a slider that will control the size of our terrain's peaks and valleys. Drag a horizontal slider from the Input Widgets section into our window, along with another label. Name the label Peak Valley Size and adjust the font so it's less prominent than the title. Here we're going to use MS Shell Dialog 2 at 10-point font. Rename the slider's object name property to Terrain Size Slider. In the Q Abstract Slider section, set the maximum property to 5 and the value property to 3. This limits the slider to a range of 0 to 5, with a default value of 3. Using what you've learned, import 3 more images: TE terrain low, TE terrain mid, and TE terrain high into your window. Marquee select these 3 labels, right-click, and choose Layout, Layout horizontally to position them more precisely. Now marquee select all the widgets related to the peak valley size, right-click, and choose Layout, Layout vertically to position them vertically. Resize the group so it spans the width of the window. Also, we'll adjust the middle and high icons so they sit in the center and far right of the slider respectively by adjusting each of their alignment properties in the Q Label section. Drag a push button widget from the Buttons section and name it Randomized Terrain. Just like the MEL interface, we want Maya to call our Randomized Terrain procedure when the user clicks this button. To do that, we'll add a dynamic property to it by clicking the green plus button in the right panel and selecting String. Here we'll first include a C flag to indicate we're executing a command, then place our procedure name in quotations. Save your file for now and return to Maya. We need to adjust our MEL script to communicate with our new Qt interface. Load the script Terrain Editor. This is the fully functional Terrain Editor script minus the MEL UI and is identical to the script you finished the previous movie with. Right now, the randomized terrain procedure generates valleys and peaks based on a constant value of 5. We want to change that so it generates values based on the slider value in our Qt UI. We'll replace this constant with the keyword intSlider, along with the query flag and value flag to get the value of the terrain size slider. Now we just need to create a window. We'll assign our window to a string variable called window. As with a MEL-generated UI, we must check if an instance of the window already exists, and if so, destroy it. We can use the load UI command to load the terrain editor file we created in Qt. Finally, use the show window command to actually display the editor. Now you can run the script to display the Qt interface. Your interface generates peaks and valleys according to the value of the slider each time you click the button. Compared to our old MEL-generated UI, the Qt one has the same functionality, but actually looks a bit nicer thanks to its fonts and icons. Let's return to Qt Creator and design the rock tree controls of our UI. First, increase the height of your editor by dragging the edge of the window down. To save some time, marquee select the peak valley size widgets we created previously and control-drag the mouse to create a copy of them. The rock tree portion of our UI needs 2 sliders, one for the density and another for the ratio. So control-drag a second copy of the same widgets below your initial copy. Rename the labels for the first and second sliders Rocks Trees Density and Rocks Trees Ratio, respectively. Rename the sliders Rocks Trees Density Slider and Rocks Trees Ratio Slider, respectively, and set their min and max values to 0 and 100 and their starting values to 50. We'll also replace their respective icons with those marked Density and Ratio from the Icons folder. Finally, Control-drag a copy of the Randomize Terrain button below your Rocks Trees widgets and rename it Randomize Rocks Trees. Since we copied this from the existing button, it's already set up to call the Randomize Terrain procedure. Select the button and scroll down to its Dynamic Properties section. Select the existing string here and click the red minus button to remove it. To make our workflow even easier, we're going to add two commands to this button. Call the Clear Rocks and Trees procedure, then the Randomize Rocks and Trees procedure right after it. This will save us from having to click a separate Clear button every time we want to generate new rocks and trees. However, for completion's sake, you should still create one last button called Clear Rocks Trees and assign it your Clear Rocks and Trees procedure, just in case you ever want to run the clear command on its own. Save your UI and return to Maya. We'll alter our existing procedures to make use of our UI widgets, just like we did for the terrain randomization. Set the density variable to query the Rocks Trees density slider and the ratio variable to query the Rocks Trees ratio slider. You can run the script again and try out your fully functional interface. Now you can generate new boards over and over simply by adjusting the sliders in your interface and clicking the buttons.